All right, let's talk about a little bit about aldosterone. Okay, so what do we know already about aldosterone? Because we should be very familiar with aldosterone because we looked at it in the chapter about hormones, the endocrine chapter. So what do we know about it? It's a mineral corticoid. Okay. It's a steroid. Okay. It is let's see. It's a steroid, sorry. And it's produced in the adrenal cortex. Okay, so we basically know all that, right? So what has this got to do with the kidney? Well, you see the beginning part of the nephron here, the corpuscle, whatever, and the capsule here, the glomerulus, the efferent and afferent arteriole. And let's go ahead and add our distal convoluted tubule. And we remember at the distal convoluted tubule, we've got a set of cells here. These cells are called macula densa cells. Okay, and what do those cells do? They monitor the filtrate. So they basically monitor sodium levels in the filtrate. All right, we also have another set of cells. Hopefully you remember. But there were a little set of cells within the afferent and efferent arteriole. And these cells were called juxtaglomerular cells. Okay, and this whole thing is called the juxtaglomerular apparatus. Okay, so we have these macula densa cells, and they're monitoring the filtrate, they're monitoring the sodium in the filtrate, and they're looking for decreased blood pressure, and they sense that through decreased sodium. Okay, so when it senses that, what does it do? Well, it secretes something called renin. And everybody should know this at this point. Let's hope. So renin. So renin is secreted by the juxtaglomerular cells, and it is secreted into the blood. And basically it converts a plasma protein called angiotensinogen into angiotensin 1. if there is an enzyme called the ACE enzyme available, when it comes into contact with the ACE enzyme, then angiotensin 1 will be converted to angiotensin 2. Okay, so what does angiotensin 2 do? Well, it causes vasoconstriction. Okay, so increased vasoconstriction. It increases thirst. And it increases cardiac output. Okay. But it also does another thing. And the other thing that it does is it increases, or it targets, it stimulates the adrenal cortex to increase aldosterone. And aldosterone, of course, causes sodium to be reabsorbed. So we already know this. We already have talked about glomerular filtration rate and how that is maintained. And this is an apparatus that helps to maintain that. And of course, monitoring the filtrate for sodium, which will increase, when low, will increase blood pressure, because that it indicates low blood pressure. Again, starts with the renin, stimulates or the macula densa cells tell the juxtaglomerular cells to secrete renin, and that will stimulate angiotensinogen to become angiotensin 1. The ACE enzyme then converts angiotensin 1 to angiotensin 2. So we've got increased vasoconstriction, increased thirst, and increased cardiac output. And then along with that, we have it targeting the cortex, the adrenal cortex, in order to secrete or increase secretion of aldosterone. So what does aldosterone do exactly? All right, so in the next video, we're going to talk about exactly how aldosterone works and what it is targeting in the kidney.